Welcome to the Defense and Aerospace Report. I'm Vago Muradian here at the British Embassy, where we are covering all things autonomous. It's an autonomous systems day here at the Embassy, from systems small, medium, as well as relatively large, or as large as you could fit in an embassy. And we have with us Adam Jacoff, who is with the National Institute of Standards and Technology of the United States Department of Commerce, and you are with the Intelligence Systems Engineering Laboratory, which I'm not sure is a long enough introduction, really.
I'll try to add some.
Thanks very much. So why is Nist in this business? You know, it's not something that is like totally intuitive that you guys would be in it, but you have one of the more interesting displays here.
Well, NIST is actually leading an international effort to develop standard test methods that allow us to evaluate, or allow everyone to evaluate, their own robotic capabilities. Robot capabilities, operator proficiency, readiness, all of those metrics can be tied to a series of basic standard test methods, and we are leading an international community to get that going.
And what are some of those parameters that are important to standardize on a global basis?
Well, so we're working ground robots, we're working aquatic systems, and what you see here is a small subset of the aerial system test methods. Aerial systems, drones, as a lot of people call them, real emerging technology that show real impact for emergency responders, firefighters, search and rescue, and of course military. Internationally interesting. So we've developed some test methods to assess their capabilities, to measure things to statistical significance, so that people can be really confident that when it says it does that level of endurance, that level of visual acuity, that level of thermal acuity, you know how to deploy that system effectively.
Which is key for any commercial product, right, as it makes a transition into the real world.
It's extremely important, but it's most important to just align the expectations. There's a lot of marketing, of course, there always is. But aligning the expectations of the user communities will make them use the technology more effectively. Something as simple as visual acuity. From a hover altitude defined, say, 100 feet, can I read license plates? Can I read better? Or is it much, much worse? Thermal acuity. I'm looking for someone lost in the woods. I need a certain level of thermal acuity in order to be effective. The basic test methods just get everyone talking apples to apples.
And what is the international body you guys are working with or through, and how many nations are involved in this effort?
So, good question. The standards themselves, so NIST itself is not a standards development organization. We're sort of the technical lead to develop the underlying measurement science. But the standards are being standardized through ASTM International. There's a committee on Homeland Security Applications, Response Robots. I chair that committee. Secondary standards organizations are referencing those standards, and they will set thresholds for their user communities. So an example of that would be the National Fire Protection Association, NFPA, has a new standards committee for NFPA 2400, all aerial systems for public safety. So they know their firefighters, they know their EMS people, they know what they need to do, they can set knowledgeable thresholds of performance.
And also for commercial applications, there are now, you can buy drones that a couple of years ago did not have any much of a commercial analog to them. Folks could build them, but it was an expensive sort of thing, and generally it was in the purview of militaries. Now there are also lots of concerns about, for example, whether or not a commercially acquired unmanned system can somehow become a weapon or anything. From a commercial trade standpoint, what are the role that you guys have to play in sort of the standardization and the commercialization of this important market that, there's a little bit of trepidation for it, but there's also a lot of enthusiasm, on both sides of the equation?
So it's certainly moving very quickly, and we are not working on counter UAS, although people are. What I would say is that every emerging technology is going through this disruptive sort of cycle, and the aerial systems just might be more so because they're smarter than your average robotic system out there. The fact that it flies by itself for the most part means it's deploying GPS, it's positioning. In this case, they're adding optical flow. Basic capabilities, technical capabilities, improve their usefulness because they make it easier for a remote operator to use. That's why the aerials are taking off. Ground robots need to do the same thing. Remote teleoperation is very, very difficult. Anyone who thinks a remote-controlled RC car in Fukushima is going to work is deluded. What they need is a system that works with them, where what the robot can do with onboard sensing, centering between obstacles, mapping the place they've been, when they go beyond radio communications, turn around and come back to where it was clear, or I would have lost it. basic autonomous assistive capabilities will improve the capabilities of the remote operator and the success of the mission. It just happens that flying is easier than ground terrain, and so it's happening faster.
And what we're seeing behind us is a Mavic that's been going around and checking us out while we've been doing our interview. This test over here with this Mavic in the background that's been kind of going around while we've been doing this interview. Talk to us about what's happening here, but also how you guys are going to be interfacing and working with the FAA, because this is still an aircraft. It can go up to a range that's or an altitude that's significant for a potential accident with, for example, in Washington, D.C., obviously very controlled airspace, but you don't have to go very high before your presidential helicopter, especially right here, right next door to Vice President Pence's house. Talk to us a little bit about what you're doing in that interface with the Federal Aviation Administration.
Okay, so the idea is the FAA has an interest in not having everyone just throw their Christmas present up into our national airspace without some due diligence. So they've developed a Part 107 written test that is a knowledge exam. So they can at least assess whether you and I are actually so unknowledgeable about the airspace that we didn't know we were right next to a secure property or the nearest airport or the other hazard. So that's been done. Now what we have here, since we have these developing standard test methods, we can actually assess your operator proficiency. So not only are you knowledgeable, but maybe you're actually pretty good at it or not. What we set up here, because we had such a small space, was really the operator proficiency set of tests so you can practice. So you unwrap your Christmas present, what's the first thing you do? You want to fly it? Well, being in a netted environment, very good idea. Being inside a basketball court, even better idea, right? Not in the national airspace. So we advocate working your way out of the controlled spaces that don't allow any conflict until you generate a level of proficiency, a measurable level of proficiency against the standard set of tests. So we're working with the FAA and others. There's curriculums out there wanting to do exactly this. They would adopt the tests, they would set some thresholds, and they would teach everyone how to go through those tests and then maybe certify in the end, although certification is a fraught term. You can think about other angles of this, which are the FAA has an interest in maybe setting weight limits, and they have small unmanned aerial systems, 55 pounds and under. So we have an impact forces test that we've developed with the FAA and others, ASTM, to sort of assess the impact of one of these systems coming down uncontrolled. Another reason why you don't want to be flying outside the net is you do not want to be flying over people. It is not legal to fly over people. And that's because these things are inherently dangerous. Any weight, any pointy object in the air above you is a problem.
Especially one with 4 whirling blades on it.
And there's that, but literally a spear would hurt too.
Yeah.
So we have an impact forces test method at NIST.
I hear that hitting people with a microphone hurts also, I'm told.
I hope I don't find that out, but you know, I'll stay on your good side here. Just having common test methods to start talking about the capability, impact forces in this case. Next, the developers would say, well, I got to pass that test. I'm going to put a parachute on my system. So when it has a failure, it will parachute down, slow its momentum, pass the test because it didn't pass on the energy to your head. That's a perfectly legitimate way to get around the test methods, is have an advent in the capability, and now we're testing whether your parachute deploys properly. Good story, either way.
Adam, thanks very, very much, and best of luck to you guys.
Pleasure.